Welcome again in our option pricing cal- calculation. Already we have explained how we can calculate option price when single time frame or two time frames are considered. The overall concept that we have discussed is related with call option. Although for single model, a single time frame, we have shown it for put option also. Gradually, we will extend the multiple time option again for put option. But for the time being, now we are moving to a different area. Different area means actually we are developing a new formula for calculating the probability that we have used earlier in solving our previous problem. We already mentioned the formula of probability is based on the concept of risk neutrality. So, by applying this formula, the probability that we are getting is eliminate the scope of arbitraging opportunity. The simple formula was P is equal to R minus D by U minus D, where R is the risk-free interest rate. But in practice, what we are doing today, we are not considering the risk-free rate that is given in the problem. Rather, we are substituting it by continuously compounded risk-free rate. Continuously compounded means if the risk-free rate is compounded in every fraction of time on continuous basis, then what will be the effective risk-free rate during the option life? This is called continuously compounding risk-free rate. This rate is estimated by using this particular formula, e to the power RT. It should be RT instead of RT. So T means time frame. Here we are considering each time frame equal to 1 year or one period. So whatever we have shown in the formula e to the power RD, this D should be replaced by e to the power RT. It is typing error. That means our formula of continuously compounding P will be e to the power RT, which is nothing but continuously compounded risk-free rate. Previously, we were using only risk-free rate, but this formula will give us more accurate result than the previous one. So at present, whatever we are calculating in practical field, we are applying this continuously compounded rate. So our probability formula is e to the power RD minus 1 minus D. Here D is considered as positive value because already we have taken 1 minus D. No, actually this is also an error in typing. It should be e to the power RT minus D. 1 minus U if I write, then it is okay. So actually my formula will be P is equal to e to the power RT minus within bracket minus G. And in the denominator, it will be U plus D, where the D value will be negative. Okay. So on the basis of that, let us see how we are doing the calculation. No, the formula is okay. Actually, e to the power RT will be 1 point something. where 1 is the principal amount. So 1 is deducted here. So actually it is e to the power RT minus 1, then it is plus D. So that minus 1 and plus D has been put in the bracket with minus common. That is why it is 1 minus D. So this formulation of the formula is quite okay. It is P e to the power RT minus within first bracket 1 minus D, and the denominator is U plus D. So just see the calculation that we have shown here. It is 2.7183 to the power 0.06 into 1. To the power R is 0.06 and 1 is the time frame, which is 1. Minus, then 1 minus downside is 20%. So 1 minus 0.2, and here it is 0.25 plus 0.2. So ultimately the calculated figure will be 0.5819. Just see, the figure is varying a little. Instead of 0.5778, now it is 0.5819. So in future, in all our calculations, we will use this probability formula. Now we are considering a particular example where stock price is 100, upside 25%, downside 20%, risk-free interest is 6%, and now it is 3-period model of 4 months each. That means 1 year will be divided into 3 phases, 4 months, then 8 months, then 12 months. So on the basis of that, we will go to the next slide and we will try to develop the model. In step 1, as usual, we have calculated the probability using the same formula, and the E becomes 1.0212. From this we have deducted 0.8 and now we have divided it by 0.45. This is the result that we are getting. So now just see, the entire time phase has been divided into T, time 0, time 1, time 2, time 3. Just look at the figure. Spot price is going up from 100 to 25%, 125 in time 1, then again 25%, it becomes 156.25 in time 2, and finally again 25% of 165.25, it becomes 195.31. In this way, each time figures are changing. Now, in the downside, from 100, it has moved down to 80. Then, if it is 125 in time 1, then in time 2, upside will be 156.25, downside will be 80% of 125, that means 100. If it was 18 time 1, then with 101.25 multiplication, it will be 100, and with 0.8 multiplication, it will be 64. So in time 2, we are getting 3 spot price 156.25, 164. Now, 156.25 in time 2, again will be an upside movement, downside movement. For upside, we have already stated 156.25 into 1.25, it is 195.31. For downside, it is 165.25 into zero point 0.8 is equal to 125. And this 100 with 25% upside will be 100 into 1.25 is equal to 125. Downside 100 into zero point 0.2, 8.8 is equal to 80. And this 64 with upside movement will be 64 into 1.25 is equal to 80, and in downside movement 51.20. So spot price in time 3 can be 4, either 195.31 or 125 or 80 or 25. Intrinsic value of the call option will be positive only at 195.31 and 125, and it will be 0 at 80 and 20. With this discussion on T, we are concluding this lecture. We will continue in our subsequent lecture on this particular area. Thank you.